Have you ever looked at a spreadsheet and just had this feeling that the numbers were trying to tell you something, but you couldn't quite figure out what? Well, you're in the right place. Today, we're going to unlock those secrets. We're going to pull back the curtain on the world of data and show you how to make those numbers talk. And I promise it's way more interesting than it sounds.
So get this quote: statistics can be fun, or at least they don't need to be feared. I know, some of you are probably rolling your eyes right now. For a lot of us, the word statistics just brings up nightmares of pop quizzes and concepts that never quite made sense. It's a real thing. It's called stats anxiety. But here's the secret. You're already using statistics every single day. The trick isn't about memorizing formulas. It's about understanding the story that the numbers are telling.
And with that, welcome to the Flow Tao Salon, the place where we tackle complex ideas and make them simple. In just the next few minutes, we are going to completely reframe how you see numbers, turning them from something to be afraid of into one of your most powerful tools for making sense of the world. You ready? Let's get into it.
Believe it or not, the entire massive field of statistics really just boils down to two main jobs. That's it. First, describing something that's already happened. And second, making a really good guess about what might happen next. Describing versus guessing. Let's break that down a little more.
So on one side, you've got descriptive statistics. I want you to think of this as being a historian. You've got all the facts, the complete set of data, and your job is to summarize it, to tell the story of what happened. Then on the other side, you've got inferential statistics. Now, you're not a historian, you're a detective. You only have a few clues, a small sample of the data, and you have to use those clues to make an inference, an educated guess about the whole crime scene. Let's make this real. When we talk about descriptive stats, we're talking about the what is. For example, a baseball player's batting average isn't a guess about their next at-bat, it's a hard summary of how they've performed so far. Or the U.S. Census, that's a huge project to describe everyone in the country. These aren't predictions, they are factual snapshots of a reality we have measured. But inferential stats, that's all about the what if. Look, there's no way we can ask every single nurse in a country how they feel about their job. It's just not possible. So what do? We ask a smaller group, a sample, and we use their answers to infer what the bigger group probably thinks. Election polls, TV ratings, they do the exact same thing. They take a small piece of the puzzle and use it to guess what the whole picture looks like. Okay, so stats can either describe what is or guess what could be. Got it. But to do either of those jobs right, you have to understand the secret language of your data. And here's the thing, not all numbers are created equal. I like to think of them as having 4 totally different personalities, and each one plays by its own set of rules. So let's meet the team.
First up, we have nominal data. This is the most basic personality you'll meet. Think about the number on a basketball player's jersey. Michael Jordan wore number 23. That doesn't mean he was mathematically greater than someone who wore number 8. It's just a label, a name. You wouldn't add up jersey numbers and divide to find the average player, would you? Of course not. That's nominal data. The numbers are just names in disguise.
Next up, meet ordinal data. This personality is all about order, about rank. Imagine a race. You have a first, second, and third place finish. Great. We know the order of who was fastest. But here's the catch. We have no idea how far apart they were. The first place runner might have finished a full minute ahead of second, while second place only beat third by a half second. The ranks tell us the order, but they hide the distance. That's the key to ordinal. Order, yes. Equal spacing, no. Now we're getting a little more sophisticated with interval data. With this personality, the steps between the numbers are finally equal. The jump from 10 to 20 degrees Celsius is the exact same 10-degree jump as from 80 to 90. But, and you have to catch this, the 0 point is totally arbitrary. 0 degrees Celsius isn't the absence of all heat, right? It's just the point where water freezes. And because 0 is just another point on the line, you can't say that 20 degrees is twice as hot as 10 degrees. The math just doesn't work that way.
And that brings us to our last and most powerful personality, ratio data. This one has it all. It's got the equal steps of interval data, but it also has a true absolute 0. Think about things like height or weight. A weight of 0 means, well, a complete absence of weight. And because you have a true 0, you can finally make real ratios. A person who weighs 200 pounds is, in fact, literally twice as heavy as someone who weighs 100 pounds.
This chart right here sums it all up perfectly. You can see how each data personality builds on the one before it, adding a new piece of information. Nominal just tells you things are different. Ordinal tells you the direction of that difference. Interval tells you by how much. And finally, ratio gives you the whole shebang with an absolute 0 starting point. So,
Why does all this matter? Well, let's see how this all works in the real world with 3 simple rules.
Okay, that was the theory part, but what does it actually mean for you? How does this stuff help you in your job, in your business, or even just in trying to figure out if that news headline is telling you the truth? We can boil everything we just talked about down into 3 golden rules for putting your data to work.
Here they are. So simple, but so powerful. Rule number 1, know your goal. Are you describing or are you predicting? Rule number 2, know your data. What's its personality? Is it a label, a rank, or a measurement? And rule number 3, know the assumptions. What shortcuts are being taken to get to the final answer?
Let's start with number 1, know your goal. In the business world, this is everything. Are you just describing your current customer base to your team? Cool, that's descriptive. You're being the historian. But are you trying to use that data to predict what the next big market trend is going to be? Now you're being the detective. That's inferential. You absolutely have to know which game you're playing because your entire strategy depends on it.
All right, rule number 2, know your data. This one is huge in marketing. Let's say you're building a customer survey. Asking people to rank their top 3 favorite products gives you ordinal data. You'll know which one they like most, but not by how much. But if you ask them to rate each product on a scale of 1 to 10, you get a totally different kind of data. The way you ask the question completely changes the personality of the answers you get back, and that determines what you can and can't do with it.
And that leads us to what I call the ordinal dilemma. Our source material puts it perfectly. Theoretically, as this represents ordinal data, this computation should not be done. What are they talking about? They're talking about those 1 to 10 satisfaction scales. Technically, that's ordinal data. We don't really know if the jump from a 7 to an 8 is the same as the jump from a 2 to a 3. So theoretically, you shouldn't be calculating a mathematical average from it.
And this brings us home to our third and final rule. Know the assumptions. In the real world of consumer research, people average those satisfaction scores all the time. It's a shortcut. To do it, they have to assume that the scale is an interval scale, that the psychological distance between a 7 and an 8 is identical to the distance between a 3 and a 4. It's not necessarily wrong, but it's a huge assumption. A smart data consumer knows when these shortcuts are being made and takes the result with a grain of salt.
So, let's wrap this up. Here at the Flow Tao Salon, we've unpacked the 3 most important ideas for understanding data. First, in business, know your goal. Are you reporting on the past or predicting the future? Second, in marketing, know your data. Asking for a rank is not the same as asking for a rating. And third, in consumer research, know the assumptions being made, especially when people start averaging things that maybe shouldn't be averaged. If you keep these 3 rules in mind, you can cut through the noise and get to the real question you should always be asking. What story is your data really telling?